Canon recently released firmware version 1.8.1 for the EOS R5, and its headline feature was the introduction of IBIS high-resolution shooting. This is, of course, Canon's implementation of a pixel shift super resolution imaging technique. Unfortunately, Canon's implementation of this somewhat niche feature is ultimately quite flawed. What's up, everybody? I'm Jason, and welcome back to some more tips and tricks for the Canon EOS R5. So in this video, we are going to be talking about Canon's new IBIS high-resolution shooting mode that, as I said, came out in firmware 1.8.1. So, as I implied in the introduction, this is Canon's implementation of a pixel shift multi-shot super resolution technique where the camera uses the in-body image stabilizer to shift the sensor around, shoot multiple images, upscale them, align them, stack them, average them, and create an image that ultimately has much higher resolution and much more detail than the original 45 megapixel sensor would support. Now, this is a technique that's been available in other cameras from other manufacturers. It's a common feature found in Sony's cameras. It's even found in some Hasselblad cameras. This is Canon's first foray into this market, and ultimately, you can trace this technique back at least more than a decade to shooting handheld, up-resing in Photoshop, aligning and stacking the images and getting the same kind of process. Now, what exactly Canon is doing in their cameras to do this processing in camera is somewhat of an open question, as they do seem to be using some kind of processing shortcut or something, as there is an interesting artifact that comes up in this process that we'll be talking about quite a bit in this video that I have never seen in my experience with multi-shot high-resolution processing, doing it the old-fashioned way. So let's start with the brass tacks. What does this get you? Well, it gets you a lot more resolution, 402 and change megapixels to be exact. It's an image that's 3 times wider and 3 times higher, or 3 times the size, depending on how you want to say it, of the native 45 megapixel resolution that comes out of the sensor. So ultimately, you'll be given an image that's 24,576 pixels wide by 16,384 pixels high. File sizes tend to be in the range of 50 to 70 megabytes, though they are compressed, they are JPEGs, and the exact size of the file will depend upon the subject matter, how much detail there is, how much noise there is, so the ISO that you're shooting in the camera, and so on and so forth. Now, one other benefit of this process is that, as with any multi-shot process that involves averaging tends to reduce the noise in the image and helps improve dynamic range as well, as it reduces the noise floor. And therefore, these images can actually come out somewhat cleaner from a noise perspective than you would expect from either a straight-up 402 megapixel camera or from the 45 megapixel image right off the sensor, or if you stitch together, for example, a multi-row pano of just the 45 megapixel images from the sensor, these will be somewhat better in terms of noise, usually. Now, as I said, there is a big limitation to this, and that is there is a real propensity for problems with moving subjects. Now, this isn't always the case. In fact, this seems to be somewhat of a weird, anomalous behavior that I don't really understand, because it only happens sometime. Now, Canon does warn about this in the manual when you read the section on the IBIS high-resolution shot settings, that in certain circumstances with moving subjects, you can get a mesh-like artifact on that subject. Now, what I've found in my testing is that this tends to happen around high contrast subjects. So a white thing on a black background, or a black thing on a white background, or a bright light in a dark area, or something to that effect. And the mesh pattern ends up being, in my opinion, kind of image ruining. In my experience with the stack in Photoshop solution, you don't see this. Instead, you just get kind of a blurry area, like motion blur, which is essentially what it is. In this process, for some reason, you get very hard vertical and horizontal lines that form sort of a mesh that are pixel level, so that each line is about a pixel wide. Now, on top of the mesh artifact, which is going to be, as I said, a repeating issue that I talk about in this video. There are some other limitations that you run into with this process. So as I alluded to at the start, this is only an in-camera JPEG, or the result of this is only an in-camera JPEG. There is no option to have the camera just do the pixel shifting and save out the raw files or save out 45 megapixel JPEGs so that you could stack and process them later in software of your choosing, or for that matter, if you decided after the fact that you really didn't need a 400 megapixel image of what you were shooting, just use one of the lower resolution source files. You also can't use HEIF files either. The only way to enable HEIF on the R5 is to put the camera in HDR-PQ mode, and this and that are incompatible. Second, the camera uses the electronic shutter for shooting these collections of images or these high-resolution images. So this is kind of a pro and a con thing. It's not necessarily a bad thing. It's not necessarily a good thing. There are some limitations and some benefits that come from this. So on the limitation side of things, the electronic shutter does limit the dynamic range. On the R5, the electronic shutter is limited to 12 bits, which means it can store a maximum of 12 stops worth of dynamic range. Now, this ultimately is a bit of a wash, as the file is a JPEG, and JPEG files can only store 11 to 12 stops of dynamic range anyway, so you've kind of got a matched input and output situation, so it's not like you're leaving much, if anything, on the table. Additionally, because it is the electronic shutter, you can only have a minimum shutter speed or a maximum shutter speed. The longest shutter speed you can use is half a second. So half a second to an 8,000th of a second. You can't have an exposure any longer than that. But on the flip side, because the camera is using the electronic shutter and it does shoot the images, the pixel shift images in continuous drive mode, which with the electronic shutter speeds permitting, allows you to shoot at up to 20 frames per second. It does get through the process of shooting all 9 of the constituent images relatively quickly. If the shutter speeds are high enough, I saw total exposure times of less than a second in some instances. Finally, there are a host of other things that can't be used or combined with this. If you scan through the menus, especially the shoot menus, anything that can't be used with the high-resolution shot mode will be grayed out and disabled. But there were 3 things that I specifically wanted to touch on as being real limitations. So first of all is image stabilization. It's disabled. Now, obviously, the camera is using the in-body image stabilizer to do the pixel shifting, so it's not like the camera has locked it out completely, but it is being used for something other than stabilizing the image. If you have a lens with image stabilization in it, that will be locked to the center position and not used at all. Second of all is you cannot use this with exposure bracketing. Now, you wouldn't want to bracket the exposures in each of the frames or bracket the subframes in each of the high-res shots, but when I first ran into this and realized that it was a JPEG file, my first thought was, well, shoot 3, make an HDR, and you could stitch that together in Photoshop or whatever, and you would have the limitations of the JPEG in terms of dynamic range and whatnot. You could kind of overcome that. Unfortunately, you can't do that with exposure or automatic exposure bracketing. However, you do have full control over your camera settings, so shutter, aperture, and ISO, as well as exposure compensation. So you can do the brackets manually, but you don't have any way to automate them. Finally, EFS and RFS lenses, doesn't matter which ones, are incompatible with this, as well as the 5.2 millimeter dual fisheye lens. So if any of those are connected to the camera, you won't be able to enable the IBIS high resolution shot mode. So let's talk about getting this going. You will find the setting in photo mode on the Shoot 5 menu at the bottom of that menu page under IBIS high resolution shot. There you will find, if you select that menu, you will find 2 entries, one for disable, one for enable. Obviously, enable turns it on, disable turns it off. Also note, this function auto-cancels or returns to disable when you turn the power off on your camera with the power switch, but it will not auto-disable when you when the camera auto-powers off or goes to sleep automatically with the self-timer. So you will, if you're expecting the camera, if you left the camera in IBIS high resolution shot mode and you're expecting it to be there when you turn the camera off, turn it back on. That won't be the case. You'll have to enable it again manually. Now, this is a bit of a niche technique, a niche setting, and it has some quirks to its implementation. So how do you go about doing this? Well, first of all, you're going to want a tripod. A beefy tripod is preferable, as any kind of camera movement or subject movement, of course, can cause you to have those mesh error or artifacts, which you don't exactly want in your images. You'll then, of course, turn on IBIS high resolution shot and compose your image as you want it, and set up your exposure settings. Now remember, you are creating a JPEG here. It's not a RAW, it's not an HEIF, so you're going to want to get the exposure settings as close in camera to the actual image that you want, because you're not going to have a lot of leeway for post-processing, at least in terms of, say, lightening shadows or making major exposure adjustments. Also, techniques that you might use, for example, expose to the right to optimize raw file image data, you don't want to use those here. Finally, shutter release or shutter drive mode, you want to either set your camera to the 2 or 10-second timer, or use a cable release, whether it's a wired one, an infrared one, or the wireless capabilities like with a smartphone, to trigger the camera. Again, you don't want to add any more motion to this process than you absolutely need to stay away from those artifacts. So, with talk about how all of this works, I wanted to look a little bit at how good it works. So I decided to take a look at how the high-res mode compares to just a 45 megapixel image straight out of the camera, as well as the results of some post-processing upscaling capabilities like you have from, say, Topaz Labs Gigapixel AI or Photo AI, or the super resolution AI-assisted upscaler in Photoshop and Lightroom. So compared to the 45 megapixel image out of the camera, your results are obviously higher resolution. And it's real resolution. This isn't some kind of BS process to fake upscaling. There really is more detail in the files, as long as you don't run into, say, moving things. So it does give you a benefit in that respect. Also, you end up with one big file, which from a logistics perspective is also a positive thing. If you're doing this manually, you're going to have 4 to 16 files that you're going to have to stack. If you just did it in the camera, if it could put out the raw files, you'd have 9 to stack. You have to obviously keep those all together, organized, know what to do, know which ones are what, and so on and so forth. Now, the cons of this approach versus just a straight image out of the camera is really the mesh artifacts. Anything that moves is subject to them, although it's mostly a problem for things that are very high contrast, but this is obviously not a problem at all for anything that's shot in a single image. Additionally, it's a JPEG. You don't have the option for a RAW file, so increased dynamic range, the ability to process more things and better tonal gradations due to the higher bit depth, they're all out of reach in that respect. So I shot some test images with this, and I ran into some interesting sort of observations in practice. So to start with, the 402 megapixel images are somewhat softer than I'm used to. They certainly require sharpening somewhere. Now, you can, of course, sharpen them in post. You will want to probably use a much broader sharpening radius than you would use normally for your regular images. You might also want to play with the picture style sharpening settings in the camera. The way I have my camera set up, my picture style is set to not do any sharpening, so that could be a factor as well. It does appear that picture styles are applied to these huge images, so that processing is done. Now that said, this is something that I find very difficult to judge in sort of an apples to apples comparison. So on my 27-inch monitors, the 45 megapixel images that I get out of the camera natively are, if I'm looking at them at 1:1 magnification, it is as if I was looking at a 6.4 by 4.3 foot print, or a 1.96 by 1.31 meter print. That's a really big print to be sitting 21 inches or 28 inches away from looking at 1:1 magnification. For the 402 megapixel images, again, on my monitor at 1:1 magnification, that translates to looking at a little tiny part of what would ultimately be a 20 by 12.8 foot print, or a 5.89 by 3.93 meter print. So we're talking about huge images that you would never be this close to, and that really makes the judging sort of between the two somewhat difficult. The other thing I wanted to look at was versus AI upscaling. So obviously the big pro of using the multi-shot process is you do get real information out of the scene. There's no computer process making up image information to try to create what it thinks should be there. This is actual information that the camera is extracting from the process of creating these images that was in the real world and that is in your ultimate image. Now, on the other hand, the cons, again, we have that artifacting problem with subject motion, which limits where and how often you can do this, as well as the fact that you only get a JPEG out of this. Whereas AI upsampling software, although it can be flawed, can post-process pretty much any type of image file. Whether it's a RAW, a JPEG, an HEIF, a TIFF, a PNG, whatever, as well as it can upsample any kind of broad source of image. So it's not just a 3:2 aspect ratio one-off image. You could be upscaling HDRs, stitched panoramas, HDR panoramas, any of those kinds of things the post-processing software can potentially deal with. So how did this fare? Well, one of the things is this is going to depend a lot more heavily on the subject matter and the AI enlargement algorithm that you're using. So in my tests with this circuit board image, my results from the AI side of things were kind of wonky. It really didn't seem to know how to deal with the texture on some of the ICs around the text versus where it was on the rest of the IC, or where it was away from the text. And it's likely a problem with the AI training suite or training data not including this kind of imagery. So it may perform much better on something like architecture or landscape. And on the other hand, you do have the issue, again, with the pixel shift not really cutting it for anything that isn't, or anything that does move. So in that case, even with the errors the AI process might introduce, you may still get a better high resolution image out of that because you don't have the lattice or matrix or grid artifacting. So with that said, let me wrap this up with some conclusions and recommendations. So as far as I'm concerned, the mesh artifacts are a problem. You can't really see them in the review on the camera because it doesn't zoom into 1:1 magnification on these images. It only zooms into 15x magnification, which would be close to 1:1 on the 45 megapixel images. And they aren't consistent. Sometimes they occur, sometimes they don't occur. As I said, it seems to have something to do with how much contrast there is at the area that's moving and whatnot, but that becomes problematic because you don't know when they're going to happen. You know, you could be taking a picture of one landscape and that works fine, and take a picture of what seems to be a similar landscape and that has a lot of problems. Ultimately, I really need to do a lot more testing on this with real landscapes, which is just something that's going to take a lot of time because there's only so many landscapes and situations I can get to in a few days after the firmware is released. So this bears a lot more testing, and certainly if you're interested in this, I would recommend strongly that you test this in as many situations as you can before you start trying to rely on it. That said, recommendation-wise, if these 400 megapixel JPEGs are something that you actually think might be useful for you, I'd say give it a shot. It can't hurt. For me personally, this is a soft pass, at least for now. Now, if Canon comes along and updates the software to either address the mesh artifact issue or simply provide a series of RAW files that are the pixel shift, source images so that I can stack them in my own software, I may come back and revisit this as a more serious part of my workflow. And ultimately, that's kind of the part that frustrates me with this. If you do the old manual technique of super resolution, you have to shoot handheld. You can't have it be on a tripod. If you're on a tripod, that technique doesn't work, but the pixel shift or the sensor shift method does. However, because Canon has chosen not to give us the source images from that pixel shift file, or that it composites with, in any way, shape, or form, it becomes really difficult to use this. Well, you can't use this outside of the specific case that they provided. So with that said, the big underscore that I want to make here is if you do plan to use this and you're not shooting something in like a still life in a studio setting, absolutely plan to shoot a standard image of your scene for backup purposes before you do the 400 megapixel high resolution version. It'll be very difficult in the field to tell that there's an artifact problem, and if you get home and you go to look at the image and it does have an artifact problem, you're either going to be in a world of hurt to try and clean it up and fix it, or you're going to end up throwing the image away, and if you don't have at least a 45 megapixel backup, you're probably going to end up pretty disappointed in that situation. So that is the IBIS high-resolution shot mode that Canon has introduced to the R5 in firmware version 1.8.1. If you found this useful or at least interesting, let me know by hitting that like button. If this kind of thing seems like it might be your kind of thing, please consider subscribing if you're not already. And as always, thanks for watching, and I'll see you next time.